Hey everybody, so we're moving on to volumes by revolution. This is broken up into a couple of different days. So we started out with doing volumes by cross sections. That's what we did in class today. Now we're doing volumes by revolving things around the x or y axes. So I do this a little differently than Miss Vasta. I do it more similarly to Miss Burko. So I'm actually going to cross this part off. We're not going to talk about cylinders. We're actually just going to jump right to finding volumes of solids by revolution, and I'll explain what's going on. So sometimes we can find the volume of a three-dimensional shape by taking a curve and rotating it around a given axis. To do this, we imagine dividing the solid figure into circles that have been turned on their sides. So really what we're looking at is this right here is one cross section, and we're just going to use all of our cross sections are going to be circles for this for these problems. So then we are going to find the area of each circle and add them together. So again, we're still doing cross sections, it's just that everything now is going to be a circle, and we're going to find the area of each of them and add them all up together. So since we're adding, the most efficient way to do this we know is to use an integral. And we call this method the disk method because each cross section looks like a thin disk when viewed individually. So, for example, if we were to take just that pink circle, it would look like a flat disk. So, we've got some things we got to do here. The first thing, of course, is going to be to sketch a very good graph. So, if we're looking at this one up here, the curve that we actually have is this right here. This was our original curve. And then you can see that region there. The next thing we have to do is draw in the other half of the curve. So you can almost think of this as you're reflecting it. So if this is my original curve, this blue one up here, the reflection is down here. Okay. Then we're going to draw one circle to help us visualize the solid. So that's kind of like the pink part that I drew here. So this is almost like if we were to turn it on its side, it could look like a cup or a bowl maybe. But here was our original curve, here was the reflection, and then here's one of the circles to help us visualize what's going on here. So then we are going to identify the radius of the circle, set up our integral, and solve. So I know that these steps seem a little arbitrary. We're going to do some examples to hopefully help you see kind of what we're doing here. So the region between the graph f of x equals 2 plus x cosine x and the x-axis over the interval -2 to 2 is revolved about the x-axis to generate a solid. So I want to emphasize here we're revolving about the x-axis because that's going to be really important to know which axis we're revolving around. So let's go ahead and draw a picture first, and you'll notice this is a calculator question, which means we can use our calculator to just go right ahead and figure out what this looks like. So 2 plus x cosine x, that's already in there, which is awesome. And I'm going to go to the graph, and there we go. That's kind of what it looks like. So you'll notice my window goes -2 to 2 and -5 to 5, just to kind of give us a general idea of what's going on. So I'm going to go ahead and sketch that. And let's see, I know I want at least 2, 2, and 2, and I know that this kind of comes down, goes back up, and then kind of goes like that. So that's kind of what it looks like. And we can see, again, we're going from -2 to 2, which means we're going from here to, well, that didn't match up nicely, but to right about there. So we're going perpendicular to the x-axis since that's what we are revolving around. So this is really our area, and I usually kind of draw myself a little arrow over on the side. I'm revolving around the x-axis. So we're going to imagine taking all of these and rotating it around. So we need to draw a reflection of our curve. So we're going to kind of go maybe here, back down. That didn't match nicely, but that's okay. And then back around this way. So it's not exact, but you can kind of see my reflection there. Okay? And then we need to draw in a circle to help us visualize this base here. So I'm going to go ahead and draw one right here. So we can see that it kind of looks like a vase on its side, right? If my graph were a little bit nicer, but hopefully you get that idea there. So we drew the graph, we drew the other half of the curve, we found our circle right here. So now we need to identify what the radius is. So we know that the radius is right here. Okay, so since we're revolving around the x-axis, actually, sorry, let me take a step back. We know area of a circle is pi r squared. So let's go ahead and write that down. Now we need to find our radius. Since we're revolving around the x-axis, we know that everything needs to be in terms of x, and we know that when that happens, our radius is going to be top minus bottom. So if we look at this, our top function is this original curve that we drew in. So that's 2 plus x cosine x. And then the bottom function is the x-axis. And so we stop at 0 right there. Sorry, I guess I didn't emphasize that while I was drawing it, but hopefully you picked up on that's why I stopped there, because it says between the function and the x-axis. So that's our radius right there. So if I were to write the area of one of these circles, it would be pi times, we can get rid of the 0 there, so 2 plus x cosine of x quantity squared. So it's pi, this is my radius, and then squared. So we know that once we have the area of one of these, we're just adding up all of the areas because these are just our cross sections now. So that means I can go ahead and, where is my other marker? Here it is. I want to do the volume. Now, this volume is going to have a pi as a constant, so I'm actually going to take the pi out of the integral, all right, and put it on the outside. So it's pi r squared, so 2 plus x cosine of x quantity squared dx. So this is the volume of my area, and it's with respect to x. So there's my pi r squared dx. And let's see, we're going from -2 to 2. And we're just going to go ahead and put that in our calculators. So math 9, I forgot pi. Pi times math 9, there we go, -2 to 2 of 2 plus x, I should put parentheses, 2 plus x cosine of x quantity squared, and then dx. You want to make sure that you had parentheses around your actual radius and then closed your integral and gave the dx. So we get that the volume is equal to 52.429. And there we go. Okay, so there's one example. We're going to do two more. So find the volume of the solid of revolution generated when x equals -x squared plus 4 and the x-axis over the interval -1 to 1 is revolved around the x-axis. So again, excuse me, we need another, we need a good picture first, okay? So let's go ahead and draw, we know that this is a parabola. So let's go here. we know that it is up at 4 and that this parabola is going to open down. So I'm going to go here to here. And let's see, if I go over 1, down 1, over 1, down 1, and then I'm going to go over 2 and down 4. So I'm going to hit the x-axis here and here. And so I have this parabola coming through like this. Okay. Let's see, we're only going from -1 to 1, which means I'm really looking at this area in between here. Again, it told us that we are revolving around the x-axis, so I drew my lines here perpendicular to the x-axis. And I know that that's what I'm going to rotate around. And so I sketched my graph. Now I need to draw the other half of the curve. So if we imagine taking this and reflecting it down, I'm going to go down 4 units. And I know that that's going to go here. And I'm just going to kind of reflect it right here. Okay, and so this kind of keeps going. And we can draw in one of our circles. This isn't the best picture that I have on here, guys, so I'm sorry for that. But hopefully you can kind of see that here's our circle. All right, so if we rotate this area here around, we get all these circular bases here. Okay? So again, we know that the area is going to be pi r squared. Since we're rotating around the x-axis, we know that for our radius, it's going to be top minus bottom. And so if we look at the radius of this circle, we can see that the top is this parabola. So it's -x squared plus 4. And the bottom is the x-axis, which means -0. So our area is going to be pi times -x squared plus 4 quantity squared. So that's the area of one of our cross sections. Okay, so now we need to find the volume. We know that volume means we're taking an integral. So again, I'm going to take the pi out and I'm going to do an integral of -x squared plus 4 quantity squared dx. Our starting x value is -1 and our ending x value is +1 because we've got this interval right here, so -1 to 1. Now you'll notice this one is a no calculator, so that means we have to take the antiderivative here by hand. So my first suggestion is going to be, let's do the pi integral from -1 to 1. We need to expand this. All right, so that's going to end up being what? X to the 4th minus 8x squared plus 16 dx. All right, and so now we're going to take the antiderivative. So the pi is just out front. The antiderivative of x to the 4th is 1/5 x to the 5th minus 8/3 x to the 3rd plus 16x plus c, sorry, I'm running out of room, and we're evaluating from -1 to 1. Okay, so I'm going to go over here and keep going. So I've got pi, and if I plug in a +1, I know you can't see over here and here, so I'm going to focus here for a second so that you can see where I'm plugging stuff in. So if I plug in a +1, I would have 1/5 minus 8/3 plus 16 and then plus c. And then when I plug in my -1, I'd have a -1/5. That's going to become a plus 8/3 and then minus 16 plus c. So my pi is going to still just be out front. And now if I think about this, I've got 1/5 minus -1/5. So that's really, adding those together is 2/5. Negative 8/3, that becomes a negative 8/3. So it's minus 16/3. And then I have 16 plus 16, which gives me 32. And my c's end up canceling. So it looks like I'm going to need to get a common denominator here of 15. So let's see, I'm going to multiply that by 3, so that gives me 6 over 15. Multiply this by 5, so 16 times 5 is going to give me 80 over 15. And then plus, I'm going to need to do 32 times 15. So I'm going to go over here. Well, let's think about it. 32 times 10 is going to be 320. 32 times 5 is going to give me 160. And if I add those, I should get 480 over 15. Okay, let's keep going. So 6 over 15 minus 80 over 15 plus 480 over 15, that gives me 406 over 15. And then I need the pi at the end. So that is my exact answer. Okay, I know that's a lot of arithmetic going on there. Really what I need you to know, you've still got this top minus bottom. Then from here it's just the antiderivative stuff. That's the stuff that you just got to practice. You'll get better at the arithmetic the more that you practice it. We're going to do one more example because this one's just a little bit different. You'll notice it says no calculator, so it could potentially show up on the no calculator portion of the AP exam, but we're going to use a calculator just to make the video a little quicker. So find the volume of the solid generated by x equals negative y squared plus 1 and the y-axis between y equals 0 and y equals 1, so there's my interval, and it's rotated around the y-axis. So this one's going to be a little different because both of the ones we've done have rotated around the x-axis. So first we need to make a sketch. So in order to do that, I'm going to make myself an xy table over here. And I'm going to be plugging in y values. So I'm going to do -2, -1, 0, 1, and 2. So if I plug in -2, I'd get -3, -1, and I would get 0, 0, I'd get 1, 1, I would get 0 again, and then 2, I'd get -3 again. So I'm going to go ahead and draw a sketch of what's going on here. So 1, 2, 3. All right, so let's see. 1, 0, I've got 0, -1, 0, 1, and then I've got my -3, 2, and -3, -2. So I can see this is this sideways parabola. Okay, so now here's where we have to be careful. We want the volume that's generated when we take this function and the y-axis, and we're rotating it around the y-axis. So really, we're looking at this portion right here. It stops at, it stops right there. So, sorry, hold on, I'm thinking. My bad, guys. Oh, because we're going from y equals 0 to y equals 1. Wow, that took me way too long to get. I'm sorry, you guys. Just ignore me. I don't know what I'm talking about right now. Okay, so we're going from y equals 0 to y equals 1, and we're stuck at the y-axis. So that's why it's this little pink area. So I know that's a little hard to see on my graph. But we're going to rotate it around. And so if we reflect that over, we can see that it kind of reflects over to here. And then I'm going to use a different color to try and draw in one of my circular bases. So hopefully you can see that blue right there kind of gives me my circular base. And I'm going to shade it in just to make it a little bit more obvious. So it almost looks like it's a sphere. Okay. So now we need to look at finding the area. So we know that that's pi r squared. All right, and now since we're revolving around the y-axis and we're perpendicular to the y-axis, we know that our radius is going to actually be, instead of top minus bottom, it's now right minus left. So our radius is, the right side is this function here, so this negative y squared plus 1. And then the left function is the y-axis, so 0. Which means that our area is pi times negative y squared plus 1 quantity squared. So when we look at the volume, it's the integral. Here's my pi on the outside because I can pop it out. And then negative y squared plus 1 quantity squared. Now we're doing dy because everything is with respect to y. And our interval is from 0 to 1. Now again, this technically says no calculator, but to save time in your video, we're going to use our calculator. Just know that you should still be able to, you should be able to do that just like we did in example 2. So pi times math 9, and we're going from 0 to 1 of negative x squared plus 1 quantity squared dx. And so we get that this is approximately 1.676 for our volume. Okay, I know I kind of screwed up there at the beginning of this problem with our region, so if you have questions, please feel free to ask when I see you guys in class. The rest of the notes here we're going to do before you guys jump into your practice, just to make sure you're solid on it. All right, I will see you guys later. Bye!